Alright, so this is the fourth part of the video on Similarity and Congruence Unit Review Day 1. I'm going to go through the last page of the review in this video. Okay, so that's going to be 11, 12, 13. 11, it's asking you, says, the three triangles that do not overlap are shown on the coordinate grid. The coordinates of all the vertices are integers. So, and it says which statement is true. And there's four different similarity statements here. So the question is which of these three triangles, or which triangles are similar. And if you look at the thing, at the answer choices, we've got three triangles that we're talking about. ABD, EBA, and DBC. And that's here's DBC, little triangle here, little right triangle. ABD is this one here, the medium-sized one, and then EBA, which is the biggest of the three triangles. We want to know which ones are similar. Well, we have an angle in each of the triangles. We have the right angle in each of the three triangles. So that gives us one thing. So we're going to be looking for either another angle, which we're not going to have, or sides that are proportional. So let's look for, figure out which triangles have sides that are proportional. I think the easiest thing is to draw the triangles separately. So this is like DBC. And how long are the sides? Well, this side is 1, 2. This side is 1. This side, I'm not going to worry about what it is. I could figure out what it is using the Pythagorean theorem. But this should be enough, because I've got two sides, and then I know the angle in the middle, so I can always use side angle side similarity to show that they're similar. Okay, then I've got triangle DBA, and I know that that's like DB is 2, right? I just count that, and BA is 1, 2, 3. And then last I've got triangle EBA, CBE, same thing. So ABE, and AB is 3 again, and BE is 1, 2, 3, 4, 5, 6. Okay. So just looking at it, which ones are proportional? Well, it's going to have to be the same ratio of the side to the side. So the short side is the short legs. We've got the legs of three right triangles. Well, the short leg in this triangle would have to go with the short leg in this triangle, and the short leg in this triangle. So if these two, DBC and ABD, are similar, then I would have 1 over 2, 1 short leg over short leg equals long leg 2 over long leg 3. Does 1/2 equal 2/3? No. So that couldn't work. Check the other one just to make sure. I've got 1 short leg is 1 over the short leg in this triangle here is 3. Short leg, or the long leg in DBC is 2. The long leg in ABE is 6. Does 1/3 equal 2/6? Yes. Okay, so those, I've got my proportion. I have my angles, right? I know that these are both right angles. So I've got these two triangles are similar. If I look over here, it's CBD and ABE. But I also have CBD and EBA. Now, EBA and ABE are the same triangle. But remember, if we're saying that they're similar, then the corresponding parts have to match up, the corresponding pieces of the statement. So if we look at it a little closer, I'll zoom in a little bit. What do we know? Well, CB goes with which side? If we look over here, CB, the short leg, goes with the short leg here. So CB goes with AB. That means that CB and AB should be in the same position in the similarity statement. Well, CB is the first two letters here, and AB are the first two letters here. So they're in the same position. That's good. If we look at D, though, CB is the first two letters. AB is the second and third letters. So that doesn't work. So this one isn't right. It's going to be choice C. That has everything in the right order. And we can check our other side, too, that we have here, right? We know that DB goes with EB. So if we look back here, DB goes with EB. That's second and third. And then AE and DC are our two hypotenuses. So AE D, C, D. First and third, first and third. That's a kind of complicated problem. The other ones are a little bit more straightforward. So zoom back out a little bit. Good. Yeah, that works. Question 12. Using the information given, which congruence postulate or theorem can be used to prove that PQR, triangle PQR, is congruent to TSR? Well, if you look at our picture, first thing I would always do is, like, if you got intersecting lines like this, then you're going to have vertical angles that are congruent. I would just mark them on the diagram. Now I have everything I need. I've got an angle, I've got a pair of angles, another pair of angles, and a pair of sides. So it's either ASA or AAS. ASA means that ASA implies that the side is between the two angles. It's the included side. If I look over here, here's my two angles. The side is out here, so it's not the included side. The included side would be RS. So it's not ASA, it's AAS. If I look down here, that's choice D. The last question is the easiest one. If you don't know this, you would need to memorize it. The three similarity theorems are AA, SAS, and SSS. The five congruence theorems are SSS, SAS, ASA, AAS, and HL. Alright? Done.